Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it involves a new rule set, so I'm kind of excited to see what it is. Today's puzzle is called Stickman Brawl by Malrog, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 in every row, column, and region without repeats. We also have quotients, where each circle has 2 lines extending from it. Okay, so every circle does have 2 lines extending from it. And digits on each line form a single value when read from the circle outward. Okay? The digit in the circle must be the result of dividing one of these values by the other. Oh, interesting. Okay, that's pretty cool. So, and I think that's basically all the rules. So, for example, you could have something like, I don't know, maybe this could be like 44 and this is 11, right? So if you read it from the circle to the edge, so this would be the highest digit, this would be the second highest digit, etc., etc. These would be the highest digits here from the circle outward, right? So this would be the hundreds digit for these digits, this would be the tens digit for these digit, and this would be the ones digit for that digit. So if you had, as an example, this is 4, 4, this is 11. Okay, that doesn't work. Let's make this 2 and 2. If this is 4 and 4, that doesn't work either. Okay, let's make this 8 and 8. There we go. If this is 8 and 8 and this is 4 and 4, this would have to be 2 because 88 divided by 44 is 2. And so these are quotient, essentially, where each circle is the quotient of the 2-digit numbers that are going out from it. Fascinating, actually. I don't know the implications of that, actually, thinking about it. But anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, we have a lot of these quotients which divide up 2 unique digits, right? Here, here, actually, these aren't necessarily unique. This is unique, but this could be non-unique, right? And this could be non-unique. Or, no, sorry, this has to be unique. Okay. What are the possible combinations? For the unique digits, you cannot have a 1 anywhere. Oh, that's interesting. Right, so you can't ever have a 1 in any of the non-unique digits, or sorry, the unique digits. This could be a 1 here, because these both could be, they're not unique necessarily. But 1 cannot be here, because 1 times any digit is itself, and since they are unique, you can't have them be the same digit. So this can't be 1, this can't be 1, and this can't be 1 because this is a 2-digit number times divided by another digit, which gives you 1 digit, so that doesn't work. So 1 in row 1 has to be either here or here. That's interesting. Does that tell us anything? I'm not sure. Maybe, maybe not. What are the possible combinations? You can't have 4 and 2 because that would give you 2. You can't have 9 and 3, but that would give you 3. So the only possible combinations are 8 and 2, 8, 2, and 4. So 2 and 4 multiplied to 8. And I think 2 and 3 multiplied to 6. 5 does not have another divisor beside 1, and so does 7. And 9 can only be divided by 3 and 1, but then they would have to have a 3 with it or a 9 with it, which is not allowed. So these can only be... Interesting. So this has to have a 2 here. Right? It's either 2 with 3 and multiplied to 6, or 6 divided by 2, which gets you 3, or 6 divided by 3, which gives you 2, or 8 divided by 4, which gives you 2, or 8 divided by 2, that gives you 4. Either way, 2 has to be here. Well, where can 2 then be? We know every quotient rule requires a 2 if you have 3 unique digits. So, what does this have to be? This has to be a 2, which means this is either 8 and 4, because 8 divided by 2 is 4, or 6 and 3. And this cannot be 2. Actually, it could be 2 in the middle. It's 2 in the middle, which means this is also either 3 and 6. So 6 cannot be in the middle. 2 could be in the middle here. Or it's 4 and 8. And then you could have a 4 here too. We now have a 2, 3, 4, 6, 8 quintuplet, which eliminates 2, 3, 4, 6, and 8 from the rest of the row. That leaves us 1, 5, 7, and 9. So this could be 1, 5, 7, 9 in the rest of the row. This could be 1, 5, 7, 9. These have to be 5, 7, or 9. Well, if this were a 5 here or a 5 here, the problem is if you have a 5 times another number that's odd, you'll always have a 5 in the ones digit. So none of these can be 5 here. So this must be specifically 7 and 9, which multiply together gets you 63. So this has to be a 6, and this is a 3. The 7-9 pair eliminates 7, 9 in the rest of the row. So this cannot be 7 or 9. This can't be 7 or 9. This is 63. We need a 2 in one of these digits. And it has to be 2 with 4 and 8. So this is 2, 4, and 8. That leaves the remaining digits in column 9 as 1, 5, 7, and 9. And we need to have a 1 and a 5 there. That's interesting. This is 2, 4, and 8. One of these is a 2, but we're not sure which. The remaining digits in box 3 are 1, 2, 4, 5, 8, and these cannot be 2 here. This cannot be 1 because then these would be the exact same digits. This is at minimum 157. And if you multiply by 8, that doesn't work. Because that would be 1,000 and something. So this cannot be 8. This always has to start with a 1. Because if you had any other digits start there as a 5 or higher, 500 times 2 at minimum would be 1,000. And we only have 3 digits here. So this must be a 1, which means this can't be 1. This then must be double that, or so it's either 2 or 3. I guess it could be 4 times, actually. Never mind. So we don't know what that is. This is 1. This is 2, 3, 4, 6, 8. 8 cannot be in the middle here because this is the quotient. So 8 has to be the dividend. Dividend? Yes, the dividend. And the other one's the divisor, right? Same here. This has to be 2, 3, or 4 here. This is 2, 3, 4, 6, 8. This is 2, 3, 4, 6, 8. This 3-digit number must be divided by this. Oh, wait, they're both 3-digit numbers. Okay. We have a 5 here somewhere. 5 Okay, if this were 5, if this were 5 here, ooh, okay. If this were 5 here, the problem is if it multiplies by an even digit, this would have to be 0. And if it multiplies by an odd digit, this would also have to be 5. And therefore, we'd have a 5 in the same box, which breaks normal Sudoku rules. So this cannot be 5. Therefore, the 5 in column 9 has to be here. Well, if we double that, we get 1 and 5. Therefore, this would have to be at least, this would be 3 and 0 or 3 and 1. Either way, it doesn't work because we can't have a 0 as a normal Sudoku digit, and we already have a 1 in the box. So this cannot be times 2. If we multiply by, well, if we multiply by 5, whatever digit this is odd, would have a 5 in the ones place, and we already have a 5 in the box. So this cannot be 5, this must be 4. This 4 means this can't be 4. Also, where is the 2 in this box? It has to be here. So this is 2. This is multiplied by 4. We need this is basically 115 times 4. So it's either 157 or 159 times 4. 15 times 4 is 6. So it would have, I think a 6 always has to be here. Right? Okay, let's just calculate it out. 157 times 4 is 628. And 159 times 4 is 636, which is not allowed. So it has to be 157 times 4. This 7 times 4 is 28, so this is 8. 4 times 5 is 20, so 22. So this would be 2, and this would be 6. So this 7 means this can't be 7. This is 9, which makes that a 7. The remaining digits must be 3, 4, and 9 in box 6. So this can't be 4. This is a 3 or 9. That's interesting. So this could be... It cannot have a 2 here. So, either 3 or 9... What's the quotient, right? It could be 1. This could be 1 and this could be 3. Or this could be 3 and this could be 1. To multiply, or this could be 3 and 3 to multiply to 9. You cannot have a 3 with a 2 multiplying to 6. You cannot have a 3 and a 6 here because then that would be 18. So this specifically has to be 1 or 3 here, and this has to be 1 or 3. Interesting. This can no longer be 6 here. This can't be 2. So if this is 6, 3, and 2, the 6 would have to be here. So this can't be 3 ever. The 3 or 4 has to be the quotient here, which means the sides must be 2 and 8 or 2 and 6. So this is 2 and 8, and this is 2, 6, or 8 here. This can no longer be 2. 3 times... Okay, this could be 3 also, but this could actually be 9 here. Oh, wait, no, that's a quotient. Never mind. This could be 9 here, right? This could be 9, this could be 3, and that's 3. So that's possible too. I think we've got all the different quotients values. So anything involving 3 would have to be with 1, 2, and 6. But 2 can't be here. So this can't be 3, 2 with a 6. And this can't be obviously be 6, 3. That would be 18. Oh, this can't be 8 here because of this 8. So either this is 8 and this is 2, or this is 6 and that's 2. So again, 3 requires 1. Okay, it could be 1, 2, 6, or 9 with it. Because those are the only things that multiply together with 3 or are divisible by 3. So 1, 2, 6, and 9. And then with 9, it could be 1, 3, 2, and that's it. So, or 9 also. You could have 9 and 9. So it could be 3, 9, 9, 1. It's possible. Okay, what are the remaining digits in row 3? 1, 5, 6, 7, 8, and 9. So specifically, we're looking at this multiplier. 9 does not work. Actually, I guess it could be. It could be 99. Oh, no, okay. This, no, because you can't have 11 anywhere. This can't be 11 because the 1 would not be here. And 11 can't be here. So 9 does not work. 12 times 8 could potentially work as 96. So that could be the case. Unless these are exactly the same. Okay, so these cannot be exactly the same because the ones digit has to be different. So 1 is out here. Oh, that's interesting. Which means one of these is something divided by the other one's divided by 5, essentially, right? Because the quotient can act as a divisor too, right? So anything times 5, I think the 1 has to be in the tens digit for one of these, right? If you have a 2 in the ones digit times 5, or sorry, in the tens digit times 5, that's at least 100. So 2 does not work. You have to have a 1. Therefore, this must be the 1 because this can't be the ones in the tens digit. It cannot be 11 times 5. So this is never 50. It has to be greater than that. Right? Because if you have 5 times 12, that's already 60. So you can never have a 5 here. It's 6, 7, 8, 9, but you can't have a 6 because of that 6. So this must be 7, 8, 9. You cannot have a 2 be here. And it can't be 11. This is at least 13. So 8 is removed as a divisor. As a quotient, sorry. Because that only you can only have 12 times 8 get to a 2-digit number. And that doesn't work. You can't have a 1 as a basis, but you could technically have 14 here. Okay. This is 4, 3. What are the possibilities? 3, 4, 5, 7, 8, and 9 as the ones digit. You have 5, 6, and 7 here. The remaining digits in row 3 are 5 through 9. So that's fine. Let's not put those in. It's too broad still. Okay. We have... Okay, so if this is 19, this would have to be 5. And therefore, this would be 95. But it cannot be 5 at the end. Oh! Right. If this is 5 as a quotient, it's essentially 5 as a multiplier. But if you have 5 times an odd digit, you would have to have a 5 in the ones digit, which is not possible because of the 5 there. And if you have an even number in the ones digit times 5, you get a 0 here. So this cannot be 5. This is 6 or 7 then, times whatever this is. Therefore, it cannot be 19 here, because 19 times 6 is already 100 and something. That would be 54, 144. If you have 18 times 6... Actually, what can you have here? You can't have a 5 in the ones digit because of the same reasoning. Can you have a 17? 17 times 6 is already 100 and it's 17 times 6, you have 42 plus 60, which is 102. So you cannot have 7 here. So this is 3 or 4. Well, now we have a 3, 4, 3, 4 pair in column 5, which eliminates 3 and 4 in the rest of the column. Therefore, this is 2. This can't be 2 here. We're not sure what that is. Okay. So this is either 13 or 14 times 6 or 7. If it's 13 times 6, that's 78. But if this is 13, this would have to be 4 as a divisor between 2 and 8. So 13 times 6 does not work, because that would be 7, 8. Again, that would force, this 13 would force this to be 4, 2, and 8 to multiply together. So that doesn't work. 13 times, okay, so 13 times 6 doesn't work, because again, that gives you 78. 13 times 7 doesn't work, because that gives you 3 times 7, which is 21, plus 70, which is 91, but then the 1 can't be here because of the 1. So this can never be 13. This has to be 14, which makes this 3, this is a 6, and this is a 2. This can't be 6 here, which means this cannot be 3 here. 14 times 6 would have to have a 4 here, so this cannot be times 6. It has to be times 7. 14 times 7 is 98, I believe. 4 times 7 is 28, plus 70 is 98. So this is 8, this is a 9. Okay, this can no longer be 9 or 4. This must be a 3, which forces this to be 9. Therefore, this can't be 3 or 9. This is a 4. Okay. Remaining digits in row 3 are 5, 6, 8, and 9. Okay. This can't be 8, so this must be the divisor part here. This has to be the dividend. So this is 6 and 8. This is 3 and 4. Remaining digits in row 4 are 5, 7, and 8. This can't be 8 here, so this is 5 or 7. We have 5, 7, 8 here, with this being one of these being 8. Remaining digits in row 5 are 1, 6, 7, and 9. This can't be 6, so this is 1, 7, 9. Actually, where is the 9 in box 5? Can't be here, can't be here, it must be here. So this is a 9, which leaves the remaining digits as 1, 6, and 7. So 7 cannot be here, because where's a 7 in box 5? Can't be here anymore, it must be here. So this is 7. This has to be a 5, 8 pair here. Therefore, the remaining digits in box 4 have to be 2, 3, and 4. And the remaining digits in box 5 are 1 and 5. Okay, so this is 2, 3, or 4 here. This cannot be 9 here. This cannot be 9 here. Therefore, this must be a 3 times... Wait, that doesn't work. Oh, I guess this could be a 9, with this being a 1. Yeah, that works. Okay, so this can't be 9. This can't be 3 and 3. This actually has to be a 9 here. So this is a 9 here, which makes this a 1, which makes that a 5, which makes that a 1. Because 9 divided by 1 is 9. This can no longer be 8. So we have a 1, 5, 1, 5 pair in box 3, which eliminates 1 and 5 in the rest of the box. Therefore, this can't be 1 or 5. This must be 8. The remaining digits in column 7 are 6 and 7. And the remaining digits in column 8 are 1, 3, and 5. But this can't be 1 because of this one. Let's see. This cannot be 6, 7, 8, or 9. So it must be 2 through 5 here. This can't be 2 here. We have a 3, 4, 3, 4 pair in column 1, which eliminates 3 and 4 in the rest of the column. So this must be 1, 5, 6, 7, 8, and 9, but this can't be 9 because of that 9. This can't be 1 because of that 1. What is this multiplier? This is going to start with 2, 3, or 4. This starts with 2, 3, 4, or 5. Either way, then, this has to be either a 1-to-1 ratio or a 2-to-1 ratio. Because if you multiply 3 by 200 and something, you get 600 and something, and neither of those work for those for these 3-digit numbers. So this has to be 1 or 2. You can have a 5 at the end. Okay, so the remaining digits in column 4 are 2, 3, 4, 5, and 9. This could be 2, 3, 4, 5, and 9. The remaining digits in column 5 are 5 through 9. This can't be 6 or 8, though. This can't be 2. This is 5 through 9, but this can't be 9 here. Hmm. Hmm. This can't be 5 because of the 5 in the column. The remaining digits in column, we have a 6, 8, 6, 8 pair in column 6 and in box 2, which eliminates 6 and 8 in the rest of the box and the column. So this cannot be 6 or 8. This cannot be 6 or 8. The remaining digits are 3, 4, and 7 here. This is 3, 4, 7, 3, 4, 7, 3, 4, 7. One of these two digits is 6 or 8. And this cannot be 2, 6, 8, or 7. So it must be either 1, 3, 4, 5, or 9. But this cannot be 9 here. This can't be 7 because of this 7. 8 has to be one of these two digits here. Because none of these can be 8. So 8 has to be one of these two digits, which eliminates 8 from the rest of that box. What's remaining? Okay. If the only way this can be odd is if this is 1, so then these would have to be the same digits. So this can never be 9 then, because it would have to be the same digit as that one to be multiplied to 1. But we already have a 9 in that row. So this cannot be 9 here. This is 2, 3, 4, or 5. So if this is 3, What does that mean? I'm not sure. Okay. What are the possibilities to have 2 here? If this is 2, and say, well, this can't be 2 in that case. So if this is 2, if you have 3 times 300 times 2, that would be 600, which is not allowed. So this can't be the one that's essentially the divisor. So the divisor would have to be on this side, and this would be the dividend. So this would essentially be the product of these digits. So this would be 2. You can't have 300 here. This would have to be 2, which does work. So 2 and 2 there. 230 something, which could work. Or 240 something, which could work also. Ah, this cannot be a 1. If this is 1, these two tens digits would have to be the exact same digit. But that's not allowed because this cannot be 3 or 4, and this has to be a 3 or 4. So it can't be 1, it has to be 2 here, which means this cannot be 2. This has to be a 2 here. And again, this is 2 times this digit. So this is either 4 or 5 here. This has to be an even digit because it's multiplied by 2. So this is 2 or 4, which makes this either 1 or 2, but it can't be 2, or it's 6 and 7 to multiply to 12 or 14. So this could be 1, 6, or 7 here. This can never be 5 because 230 times 2 is at least 460. So this cannot be 5. To make it up to 500, that doesn't work because you need this tens digit to be greater than, to be 5 or greater to get to 500. Otherwise, there's no carry digit. So this must be 4. So this is 4, then this must be 2, because those are the only even digits there. And that must be an even digit when multiplied by 2. This can't be 4 anymore, which makes that a 3. This must be 6 divided by 3 gives you 2. This can't be 6 anymore. That makes that an 8, which makes that a 4, which makes this a 3. So this is 230 something. This must either be 462 or 472 because you have 231 or 236 multiplied by 2. So this is 1 or 6. This is 6 or 7 here. This can't be 4. We have a 3, 7, 3, 7 pair in the box, which eliminates 3 and 7 in the rest of the box. This can't be 3. These can't be 7 anymore. Therefore, this must be a 6, which means this can't be 6. This can't be 6. This 6 eliminates that 6, so this must be 7, which makes that a 6. This is 462 divided by 231 to give you 2, right? So 231 times 2 is 462. So this can't be 1 here or here. Where is the 1 in column 1? It has to be here. So this is 1, this is 6, this is 7. This can no longer be 1 here. Where can 6... This can't be 1. Where can 6 be, actually? This can't be 2 or 4, so this must be 8. Which means this can't be 8. This can't be 2 anymore, so that must be 4, which makes that a 2. We have a 3, 5, 3, 5 pair in column 8, which eliminates 3 and 5 in the rest of the column. Therefore, this is 1. This 8 eliminates 8 here, so this is 5, which makes that 9, which makes that an 8. The 4, 5, and 3, sorry, the 3, 4, and 9 eliminates those possibilities, so this must be 5, which makes this 9, which makes this 7. This can't be 6 because of that 6, so this is 8. This can't be 3 or 7, so this is 4. This 5 eliminates that 5, so that's a 1, which makes that a 5, which makes that a 1. This can't be 1, 4, or 5, so this must be 3, which makes this a 4. This can't be 3, 4, 5, so this is 9. This can't be 8 or 9. This 8 eliminates that 8, so this is 5, which makes that an 8. This 5 eliminates that 5, so that's a 6, which makes that a 5. This can't be 5 anymore here. This 5 eliminates that 5, so therefore that's a 3, which makes that a 7. It also makes this a 5. This 7 eliminates that 7, so this is a 6, which eliminates 6 from here. This can't be 7 anymore because of that 7, so this must be a 9, which makes that a 7. This can't be 8 anymore, so therefore that's an 8. And this must be a 3 because of that 7. Remaining digit in column 3 is a 5. And these must be 3 and 4. And that's a solution. Pretty straightforward. Pretty cool use of quotients. It does feel a lot like it's just like multi-products too, in a sense. But it does give you some leeway. Like, for example, this 199 situation was interesting, actually. I totally forgot that 9 could have been a quotient also, when divided by 1. So that's one thing you need to be careful about, I guess, with these quotients. Um, yeah, pretty cool. This one was fairly straightforward, but that's always good for a new rule set so that you can sort of get your sort of a grip on what essentially the restrictions become. So overall, very cool. Interesting new rule set. Um, I'm not sure how much it's going to be used because of it's very similar to multiplicative products essentially, and we've done those before with like cages, but not so much with lines. So maybe that does add a new wrinkle into things. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.